All right, so here we go for 7.5, last one in this section. So we'll get started here. So number 4, it does say that the two triangles are similar, so we know which sides and angles and everything to match up based on that similarity statement, which is nice. Okay, so we know BC is 4, EF is 12. Okay, so BC and EF are corresponding. The corresponding sides. We can tell that by the similarity statement. So again, I can make a ratio of their sides. So I could say the ratio from sort of this triangle to this triangle will be 4 to 12, right? Or in other words, 1/3 if I reduce that. So 1/3 is sort of my similarity ratio. Okay, so it tells me the perimeter is 42 and the area is 96 of the second triangle, right? So of the larger triangle, it's telling me those two things. So what I can do is I can basically say, okay, to find the perimeter, we know the perimeter is the same similarity ratio or scale factor. It's going to be the same as the sides that we already found out was 1/3. So I can say, all right, well, the perimeter of the larger one is going to be 42. So to find the perimeter of the smaller one, we can cross multiply and solve there. So basically in this case, it's going to be 42 divided by 3, which is just 14, right? So the perimeter in this case is just going to be, of the smaller one, is going to be 14. And that makes sense because 14 over 42 is sort of a 1/3 ratio, and that is good. Okay. Secondly, it gives me the area. So now the one thing we need to keep in mind is that the similarity ratio is 1/3. And that is the same thing as the perimeter, but it's not the same thing as the area. So to find the area, the ratio of the area is going to be the ratio of, the scale factor, basically the similarity ratio of the perimeter or of the sides, and it's going to be that but squared. So the first thing I'm going to do is square it. So again, that's going to be 1 squared over 3 squared, which is just going to be 1 over 9. And now that I know it's 1 over 9, I can write my proportion and say, all right, well, 1 over 9 is going to be some area over 96. So 96 divided by 9 is not going to be even, but you know what? That's okay. That's a fraction. 32 over 3 is not great, but which is the same thing as it's 10.6 repeating. That's fine. That makes sense. That still is sort of 1/9 of 96. Okay. Good. Number 1 here says using similar triangles is called indirect measurement. We did talk about that. All right. In this case, we're using indirect measurement to find the height of this Tyrannosaurus Rex. All right. It does say that basically you put a mirror on the ground, and if you know how far away you are from the mirror, and if you basically from where your eyes are, if you know how high that is off the ground, you could actually tell, if you want to look at the top of the dinosaur, you could actually calculate it if you knew how far away the mirror was from both objects, because the angle is both bouncing off of it, right? So we sort of have a angle of reflection happening here. But either way, we know these triangles are similar. They're marked as similar, so we can do that. I'm going to say that this is going to be 66 inches, right? 5'6". Actually, everything is in feet. So you know what I'm going to do? I'm going to not do that. Everything's in feet already. So what I'm just going to do is call 5'6" inches. Well, 6 inches is half of a foot, so 5.5 feet, basically. All right, so then what I can say is, well, 5.5 over 4 is going to be, so the height, the person is 4 feet away, so the height of the Tyrannosaurus, or the dinosaur, is going to be 40. So we can cross multiply 5.5 times 40, and then divided by 4. Oops, did not do that right. So I got 55. All right. And actually, that makes perfect sense. I could have probably done that in my head if you think about it. Right, 5.5 over 4. Well, if I slide the decimal point over, it becomes 40, so I could do the same thing there. But I didn't, so. All right, so there it is. Height of the dinosaur. Oh, 54 feet. Cool. All right, now we're given that these two rectangles are similar, and they give me the perimeter of and the area of this rectangle, but not of this one. Well, I can say, all right, well, the scale factor, MN, corresponds with RS, so I know that the scale factor, the similarity ratio, is going to be 4 over 6, which, again, is just 2/3. So that's my similarity ratio that I can use. So for number 10, I can find the perimeter of this one. Well, I know that the scale factor 2/3 is going to be the same as the perimeters. So the perimeter of the small one is 14, and I'm going to use that to find the perimeter of the large one, right? So I cross multiply, and basically we just divide 42 by 3. I did that at one point, 14. So the perimeter is, no, I did that wrong. Strike that, reverse it. All right, I divided by the wrong number, but it was divided by 2, which is 21. All right, so P is, the perimeter of the larger one is 21, right? Based on that. So again, the scale factor, again, we'll be using for the perimeter, but not for the area, right? So I need to sort of say, okay, for the area, well, that's going to be 2/3 is my similarity ratio. And what I need to do is actually square that, right? Or, I can square it. And that's going to be the ratio of the areas. So if I square that, I get 4/9. Okay, so 4/9 is going to be my proportion I'm going to write, and that's going to equal the area of the small one in this case, which is 12, over the area that I don't know, we'll call A. Okay, so we get, and we cross multiply 9 times 12, divide that by 4, and we get 27. So the area is going to be 27. And we should put some units here. These are centimeters, so this is going to be centimeters right there. And this is going to be centimeters squared, or square centimeters. Area is always going to be square units. All right, moving right along. So we can get the next one here. It's telling me that these pentagons are similar. And we sort of have the same situation where we know that, again, AE matches up with FK. So there it is. So we basically have a 90 over, well, I can just do it over here. So it's like 90 over 60. In other words, just 3/2 is our ratio that we can use. So again, the ratio from this one is 3/2 here. So that's the ratio of their perimeters and their sides. But the areas would be, well, 3/2 squared, which is going to be 9/4. So the ratio of actually, I'm going to change color just so it's, yeah, that's totally what I wanted. Okay, you know what? So just to make it slightly more awesome, okay, we can make it 9/4. Okay, so now we sort of have those things ready to roll here, and now we can sort of start our proportion. And I can say, okay, well, I know the perimeters is 381 of the larger one. So at 3/2, I can say, well, 3/2 is going to be 381 over the perimeter. And then again, just while I'm at it, I'll just set up this one as well, and then we can just do some solving. But we get 9/4 is going to be the ratio of the areas, and the area of the larger one is 1944, and we're trying to find the area of the small one. Okay, and again, we can cross multiply these. So we'll do 2 times 381, and then divided by, 2 times 381 divided by 3 is 254. So the perimeter is going to be 254, which I can just put here too as well. 54, that's going to be in meters. And then in this case, the area, we go 1944 times 4, we divide by 9, and we get 864. So the area is going to be 864, and those would be square meters, meters squared. Oops. And so I can just write it in here too for fun, because it was fun. It totally was fun. Stay there. Stay there. Ah, things are happening. Okay. Whatever. I didn't want it to stay up there anyway. I did. I lied. Okay. Last couple here. The ratio of the perimeter of the, so it's giving me these two triangles are similar, and it's telling me the ratio of their perimeters is 8/9. So what's the similarity ratio? Oh, well, it's going to be the same, 8/9. It's just the ratio of the area of one to the other is 16/25. So what's the similarity ratio? Well, in this case, we sort of know that like A over B squared, right? Because we know the scale factor, right? The similarity ratio is A over B, or something, right? The ratio of two sides is going to be squared. And we know that's going to be 16/25. So we're kind of just doing a reversal where we take the square root. If I take the square root of both sides here, I end up with the square root of the top is 4, square root of the bottom is 5. So my ratio is going to be 4/5. In other words, it comes down to the square root of here. So if they give me the area ratio or the areas in general, I can just take the square root to get 4/5. Okay, so there you have an answer there and an answer there. The ratio of the areas are going to be 4 to 81. So right off the bat, I can basically say that it's going to be, square root of 4 is 2, square root of 81 is 9. So 2/9 would be the ratio of the perimeters, right? So the ratio, it would be either the similarity ratio or the ratio of the perimeters. They'll be the same thing. We have a scale model question here. It says the model is going to be 1 foot to 50 foot. So 50 to 1 sort of ratio here. So 1/50 is going to be my scale factor here. What is the scale factor in this case? But that's going to be my first ratio that I can set up. It says the main cargo bay measures 15 by 60. What are the dimensions of the cargo bay? Well, we can say that 1/50. So this is going to be the model, and this is going to be the actual one. So we're talking about the actual space shuttle. It's going to be something over 15, right? And then we're also going to have another one with the same scale. That's going to be something else, right, over 60. So we can basically just do so when we divide this out, so it's basically going to be 15 divided by 50, which is just 0.3, right? 3/10 is fine, or 0.3. So it's going to be 0.3 feet, right? Which is what our width is going to be, wide. And then our length is just going to be, well, it'll be 60/50, which is just 1.2, right? So we get y is 1.2. So the actual dimensions not the actual dimensions, the dimensions in the model will be 0.3 feet wide. So that'll be the width. And then the length is 1.2 length. And those are feet. So you could convert those if you wanted to into inches. It said everything was in feet, so I think that's probably okay. So that would be sort of our answer there. Okay, a couple more multiple choice ones here. They tell me that they're similar. These triangles are similar over here. It says the area of ABC is 24. And then it says, what is the area of it? So first we need to find the scale factor. So the scale factor from the big to small, right, is just going to be 10 to 15, right? So 10/15, we can reduce that to 2/3. So the ratio is going to be 2 to 3. That's of their perimeters or of their sides, right? But I can square those, right? So if I actually square this 2/3, 2 squared over 3 squared, it's just going to be 4 to 9 is the ratio of their areas, which is what I'm concerned with because they're giving me the area. So I can say, all right, well, the big one, the ratio of the areas from the small one, to the big one is going to be 4/9. ABC is the small one, so it's going to be 24. So I'm just matching up the tops because they're both the smaller ones. And so we're trying to find the area of this larger one. So in this case, 9 by 20 times 24, and then we're going to divide that by 4 to get 54, which is 54 square meters, which is here. So area would be 54. All right, blueprint uses a 1/4 inch to 1 foot scale, which is 0.25 inches to 1 foot. One of the rooms on the blueprint is 3 1/4 inches long. So how long is the actual room? So we can basically say, well, it's going to be 0.25, right? Is 1/4. So I'll just use that, so I don't have to worry about it, to 1 foot. So we can say, well, we know it's going to be 3.75 inches long. So how many feet would that be, basically? So in this case, we basically 3.75 divided by 0.25. We have the 1 in there, so it's going to be 15. So 15 feet long. X is 15. And then I'll just divide that up so we know this is part of this problem. Okay. Similarity ratio between two pentagons is 9/4. Okay. What is the ratio of the perimeters? Well, it's going to also be 9/4. Nailed it. Okay. What of the two similar triangles? The second triangle has sides half the length of the first. Given that the area of the first triangle is 16 feet squared, find the area of the second. So basically, it's telling me that if they have a ratio of 1 to 2, right? If it's half as big as the first, right? So whatever the sides are in the first one, let's say it was 20, well, it'll be half. So the second one will be half. So it's going to be 2 to 1 or 1 to 2. So it's either going to be like 10/20 or it could be 6, and another one will have to be 12. But either way that you get it, the scale factor, the actual ratio is going to be 1 to 2 are going to be is going to be the similarity ratio, 1 to 2. So it says given that the area. So now I know I'm dealing with area. So I don't want 1/2. I want to get the similarity of area. So I take 1/2 and I square it. Right. So 1 squared is 1. 2 squared is 4. So my ratio of the areas is 1/4. So I'm saying, well, 1/4. Right. Um, it says the second triangle is smaller. So it says the area of the first triangle is 16. So that's the larger one. So that's going to be 16. So we're basically trying to find the area here. And again, if you notice, I'm just making sure that I'm matching up. If I have 1/4, obviously the 1 is part of the smaller triangle than the 4. So I'm making sure that this one matches up. And so in this case, our area is just going to be 4 feet. All right. All right, second triangle is half the first. Yeah, so it's smaller. All right, and that is 7.5. Awesome. It was.